Okay, so this is Unit 3, and we're going to be talking about Learning Target 1, represent data on a scatter plot and describe how the variables are related. Okay, so we have a couple definitions, so you want to get out your video notes, make sure that you're along with me right now. So a scatter plot shows the relationship between two variables measured each on its own axis. Each point in the dataset represents one measure from each variable. We do not connect the points when drawing a scatter plot. So the points are just, there's no lines, it's just a bunch of points on a graph. So two variables that are linearly, so remember that linearly, oh, that's a hard word, related, so that's a line, so it looks like you could draw a straight line through it. Maybe it's not that you can, but it looks like you possibly could, are said to be positively associated when the values of one increase in the values of the other. So on a graph, that would look something like this. If they're positive, you know, there's just a bunch of dots, but they're all going in almost like a straight line up. So that would be a positive correlation. So then the same thing, it would be negative if they're doing this. They look like they're going down. So they're almost like you could draw a line right through that, straight down. I mean, if you were connected, it wouldn't be a line, but you could draw a straight line through that. So these are both said to be linear because if we wanted to, I could draw a line through this, right? Well, there's almost a straight line. If I actually use the little line thingy. If I draw a line with arrows, I can almost draw a line through this. Like it looks like it's going in a straight line. But so these are said to be linear. So this one is going up. Slope dude tells me if I was to draw a line, this would be a positive. It's puff, puff, positive. So this would be my negative correlation. This would be my positive correlation, my negative correlation. This is nonlinear. We can't draw a straight line at all through this. It would be a curve. Again, with this one, it looks like it would be a straight line, but then we have to come down and back up. So these would both be nonlinear correlations. This one I have no relation. Sometimes, a lot of times you'll see, like, there's a bunch of there's just no pattern. There's nothing, so they're not related. You can't draw a line. There's no relation at all. We always compare correlation to R being 1. So that's a perfect positive correlation. The closer you are to 1, the more perfect it is. So this is a perfect, because this would be one straight line. That's very rare that you come across that, but this would be R equals 1. It's perfect. It's a straight line. So if we look here, it's a strong positive correlation. It's still going up in a straight line. It's not perfect. So we're going to say it's about 0.9. That's very close to 1. So here's my 1. It's a straight line. This is still positive. It's going up. It's linear. So then we're just going to say we're really close to 9 because it's positive. This would be a weak one. You know, it's going up, but there's a little bit down. You could still tell that it's linear, but it's not as strong as this one, and definitely not as strong as this one. So we're just call it a weak correlation, and it's now not as close to the R as 1. It's further away, so it's 0.4. Same can be said for a negative. So now we're comparing it to negative 1. So this is a perfect negative correlation, negative 1. So this would be a strong negative correlation. It's going negatively. It's very strong. It's really close to 1. It's a negative 1. It's a negative 0.9. So then again, this would be a weak negative. There's points all over the place, but you can still tell that there's a line going down. So we're going to call it about a negative 0.4. So we compare everything to 1 and negative 1 for how strong or how weak it is. So this one, again, the points are all random. We said that things like this, when they have no linear correlation, we just say that it's really close to 0. There's no pattern here. I don't know if I'm going up, down. They're just all random points. So we can make a scatter plot. So the first thing we're going to do is we're going to give it a title. And so the title I'm just going to use a couple ages. So I'm just going to use that same thing. And so then I need to I need to number these. So I'm going to look on here. My lowest number, I think, is 33. Let me just double check. Yep, lowest number is 33, and my highest would be 76. Now, it's not just in the white, like I'm looking at all of them. It just happens that both of them the highest and the lowest during the wives. So I'm starting here, and I want to go to here, and I have 15 lines. So what I want to do is I want to start, maybe I'm going to count by threes. And the nice thing about scatter plots is that you don't necessarily have to start at 0. So I can start here at 30 and 30. I don't have to start at 0 since it's a scatter plot. So I'm already going to have this numbered right now. So I start at 30, 33, 36, 39, 42, 45. So I would copy this down. You can pause me if you need to. So again, my husband, this is in my X column, this is my Y, so here's my husband's ages, here's the wife's ages. Oh yeah, and then that couple ages. So all we're doing is we're going to see if their ages are positively, negatively, or they have no correlation. We're just going to see using a scatter plot. So all I have to do is plot these points. So this is a point. So where X is 36, my Y is 35. So here's 36, there's 35. 72, 76, 72, 75, 76. 37, 33, so 36, there's 37, 33. 36, 35, 36. Oh, we have that again. So I'm just going to can't do anything about that. Sorry, I'm just marking the ones I've already done. 51, 50, so 51. Stay on that line. Here's 51, so here's 51, 50. 50, 46, 50, here's 45, so 46, 47, 47, 47, so right about there, 50, 42, 50, 42, 37, 36, 30, 36, and 41, 41, 41. So I would say here is that this is a positive linear correlation. It looks like it's going up. So, these necessarily aren't independent and dependent variables because the husband's age doesn't depend on the wife's age and the wife's age doesn't depend on the husband's age, but they're positively correlated. So an older man normally marries an older woman. A man in his 50s is married to another woman in their 50s. A man in his 30s is married to a woman in the 30s. So it just kind of works out that way. It's a positive correlation. So before class, what I want you to do is I want you to find a scatter plot online or in the newspaper or in a magazine. Print the scatter plot out on an 8x11 sheet of paper. If you don't have a printer, then you're going to trace it on your graph paper. Make it as neat as possible. If you absolutely cannot find one, then I want you to make one up. So what you could do is you could look up online a table of values and plot that like I did. So just make it as neat as possible because we're going to be using it in class.